Welcome back. We'll look at our next next example here in this video. And actually, let's skip to example 3. The math department chair claims that the average score on the departmental final exam is 70 out of 100. To check this assertion, Professor Badrero takes a random sample of 36 students and finds that the average score is 65.9 with a standard deviation of 11. Is this enough information to say that the average score is different from 70? I'll let you pause the video and think about this for a second. Okay. All right. Answers will vary. We have a sample average that's, I don't know, somewhat less than this, but we have a large sample size, so the sampling distribution standard deviation will be actually pretty small. So maybe it could be. At any rate, our parameter that we're working with is the population mean mu. How did I know that? Because we're trying to talk about the average score, okay? And so the average score we think is 70, and our sample average was 65.9. So our alternate hypothesis, the claim that we're putting on trial, is that is the average score different from 70? So our alternate hypothesis, H sub A, is the population mean, if we were to do all test scores, is it different from 70? And remember that we can use H sub A or H sub 1. They both mean the same thing. So they're both accepted notations. So since different could be higher or lower, we don't want to use a greater than or a less than. We want to use a not equals to, which will tell us that since we could be different in the greater than or the less than way, we're going to need to have a two-tailed test. Okay. Our null hypothesis will be that the average is in fact 70 as claimed by the department chair. So a type 1 error would be rejecting the null hypothesis and concluding the alternate hypothesis when in fact the null hypothesis is true. So in this case, a type 1 error would be concluding that the average final exam score is not 70, going with our alternate hypothesis, our guilty verdict, when in fact it really is 70, which was our null hypothesis, our default assumption. A type 2 error is failing to reject the null hypothesis when in fact it is false. So a type 2 error here would be concluding that the average is 70 when in fact it is not 70 on the final exam. All right. Once again, we'll look at our mind map, our concept map here for hypothesis testing. And we saw that with the population mean, we don't know the population standard deviation of all test scores. And so we're going to use the t-distribution. And we need to have a random sample, and our sample size was 36, so we are okay to go. So we're going to use the t-distribution. And remembering that n is 36, so that tells me that degrees of freedom is 35, and our picture of our t-distribution will look like this guy. All right. Oh, let me slide that up so you can see him. There we go. So we need to find the critical values because we could be different from 70 in the too high way or in the too low way. And so we're going to pull out our t-distribution. And since this has two tails, because we could either be too high or too low when we're being different, we're going to look at the two-tail area row. And let me tell you that for this problem, let's use a 5% level of significance. So we're going to come down this column, so 5% of the area in two tails, until we hit the 35 row, and that is our critical value of 2.030. So our critical value, actually its critical values, are plus and minus 2.030. Okay, and so we mark those T sub C. The C helps us remember that that's the critical value of negative 2.030 and positive 2.030. And if we land out here, that's enough evidence, that's beyond reasonable doubt, we're going to come back with a guilty verdict. And just as a quick reminder, those two regions together make 5%. So we'd have 2.5% in this tail and 2.5% in. So let's go ahead and look at this. What if I tell you that the test statistic was negative 2.24 for the final exam problem? If we graph that on our picture, negative 2.24, notice that I'm using a T without a subscript on it, a subscript C, because that's going to tell me this is the test statistic as opposed to the dividing line critical value. And that is inside of our critical region. And as we saw last time, if you're in the critical region with your test statistic, you're in the guilty verdict region, we will come back and reject H naught and give a real world conclusion. So for our final exam score problem, you're going to reject H naught. This means there is enough evidence to conclude the guilty verdict, which was that the average final exam score is different from $70. So remember that our alternate hypothesis was mu is not equal to 70. We had enough evidence to conclude that. Note that that doesn't mean that we proved it, but that we have enough evidence to believe that. Okay. I hope that has made sense. What I want you to do now is go back and try example 2 on your own, and we'll, in the next video, step through it together after you've had a chance to try on your own. See you in the next video.